All right. Welcome to this week's Megaport live tech drop-in session, the first one for 2025. The topic for this week's session is Megaport Internet. So it's not a new product, but it's sort of had some changes. It's had quite a few things added to it and extra bits and pieces over the last year or so, year and a bit. So it's probably worth going over what it can do now and where it might fit in. So basically, we'll go through a very quick intro overview thing in case anyone hasn't seen any of the previous videos on kind of Megaport and network as a service and how that all fits together. Then we'll go into Megaport Internet as a product, run through an overview and some technical details, some use cases and what customers are doing with it, and what we typically see. And we'll go into a demo. We can have a look at what it looks like in the portal, how you actually deploy it, and then we'll have a Q&A at the end. We have comments and questions and stuff available on LinkedIn and also on Zoom. So if you have any questions or anything, feel free to put them in the Q&A panel on Zoom or in the comments section on LinkedIn. And we do upload those to the YouTube channel afterwards, so feel free to leave comments there if you have any questions, and we can use that to drive what we do for the future sessions. So network as a service, Megaport in general, basically what we do, we run a very large global private network between 800 odd data centers around the world. Customers connect to Megaport's network around the edge of that large global network and then create virtual circuits over that network to wherever it is that they might want to go. So commonly what that looks like is a customer will have a port in a data center that they're in to plug into Megaport's network. Then they'll create what we call a virtual cross connect, a virtual circuit, a VLAN basically, across Megaport's private network from that port they're plugged into in the data center to maybe a cloud provider or some other type of service provider that they want to connect to, or maybe one of their other data centers or whatever the case may be. So compared to a traditional telco, it's kind of global, it's consistent, it's API driven, and self-service, portal driven. So you can spin stuff up when and where you like. You can design the network how you like and for however long you like. It's scalable and elastic. It kind of fits that cloud model that you're probably used to with cloud providers, but in the network space rather than the compute space. So from there, basically what we're looking at today is the fact that now one of those things that you can connect to over that network is the internet. So historically, customers have used Megaport to connect from where they are to maybe a public cloud or maybe another data center, maybe some other type of service provider. The internet is now another endpoint, another service that you can just natively bring up a connection to. So it works the same way as all the other services in that from a port, an MCR or an MVE, so Megaport Cloud Router or Megaport Virtual Edge or those other two there, you can create a VXC from that endpoint to this endpoint. It's just in this case now that endpoint's the internet, and you get a public IP address on that interface, and you can use that for whatever it is you might need. So it's available, like you can see here, from all of the access products, all of the endpoint products. So you can create this VXC from a port if you need to have this internet service delivered into a data center that you're physically in and you're plugged into Megaport there. You can have it delivered to an MVE if you want to do something like host a virtual firewall or an SD-WAN appliance or something else like that, where you're building out network function virtualization and sort of global WAN type services that you're building out virtually. You can connect it into MCR if you're doing some routing within Megaport's network before it gets to your equipment. So it's pretty flexible. You can really use it however and wherever almost. It's not available in all of the countries that we operate in, but it's in quite a few, and the list is kind of growing all the time. Most of the time in APAC, you should be pretty right as far as where it's available. Overlaps pretty strongly with where our other services are available. So why would you want internet via Megaport as opposed to some other ISP or some other pathway? Basically, most of the same stuff applies that applies to all of our other products, but you can now get those same kind of features and benefits for the internet, for an internet connection. So it's instant provisioning, just like the other types of connectivity that we offer. You can spin it up in 60 seconds and it's there and ready to go. It's scalable in that you can create a connection that's anywhere from 20 megabits per second up to 10 gigabits per second in 1 meg increments. So any speed you like between those points, and you can change that whenever you like as well. So maybe you need 100 meg today, and maybe you need a gig tomorrow, and maybe you need 2 gig after that, and then 500 meg. You can change up and down whenever you like. It's the same process as changing the other types of connectivity that we offer, but now you can do that for the internet as well. There's flexible terms available. So like people are used to with Megaport, you can get this stuff on no term, on sort of per minute build, basically on demand type circuits. Or if you are going to need a long-term solution, you can term the services on 12, 24 or 36-month terms, and you get price discounts basically on those longer terms as well. We offer diversity, similarly to we do for other types of services where we have different diversity zones available. So you can have fully diverse and redundant connectivity delivered via this service. By default, you get a public IP address on the circuit that just comes with it. That's part of the service. So it's /31. You get one IP to stick on your end. You basically can point a default route at the other end, and it'll do what it sounds like. It'll function as an internet connection. So there's a few other things that that have been added over the last little while that are pretty useful, that make it a lot more flexible and fit in a lot more use cases. So as I mentioned, you get a /31 on the interface. So that's the actual interface IP that you'd configure on your device. Some customers, that's all they need. They can just point the default route out the other side of that. They have that one IP, and that's all they require. We do also support additional subnets now and BGP. So there's a lot more flexibility there. So you can see the rest of the options here. I won't kind of dig into these too much as we go. But basically, it supports pretty much the features that you would expect from any other enterprise-grade internet service. We support dynamic routing. We support passing you different sets of routes. We can give you just a default or a full table, or peer routes. Most of the things that you generally expect from an enterprise internet service are available, and they're available on demand and flexibly, and all the other bits and pieces that Megaport's known for. So one of the things that one of the use cases for this, and one of the things that makes it interesting, is that a lot of customers will already have some connectivity to Megaport. They'll already have a port plugged into their equipment in a data center. Maybe they've already got an MCR or MVE doing some cloud-to-cloud routing or something like that. You can add this internet connection in as just another VLAN, right? So you might have a port that you currently use to connect to AWS or Azure, for example, or maybe you've got a port you currently use to connect between your two data centers. You've got a port in one and a port in the other with a private VLAN between them. You can add this in on those existing ports. It's just another VLAN delivered on those ports. So you can spin up this internet connection without having to kind of physically change any cabling. You don't need to run any cross connects. You don't need to go plug stuff in. You don't need to pay for additional cross connects. You don't need extra equipment in your rack or anything. It's just delivered as another VLAN on that existing port that in a lot of cases you might already have. So in that case, it makes it really, really quick and easy to just add this connectivity in wherever and whenever you need it. Sometimes that's a primary internet connection. Sometimes it has a secondary or backup tertiary connection. We've had a lot of customers use it for things like out-of-band management as well, where they've already got their own network and infrastructure in place. They already use Megaport for different types of connectivity. And this gives them a really, really quick and easy way to just drop in an internet connection completely separate from everything else that they're doing, that they can use for out-of-band management or other types of remote access. It's also been really popular, both as just a primary or a secondary internet connection for customers in a data center. It's pretty competitive as far as data center internet, and both in the features and the commercials. So that's one of the big advantages of this, is that it can really fit in really quickly and easily with the bits and pieces you might already be doing. But it also makes sense as a standalone product. If you're just looking for access to the internet, whether that's a small type of setup where you don't necessarily have your own IP space, you don't want to do BGP, you don't want to kind of get involved in peering and that kind of thing, but you just need an internet connection, or all the way up to someone who does run their own AS. They want to advertise their own public IPs and everything else. We can kind of support the whole range. So another kind of interesting use case that we've seen is that we have some customers who they have their own IP space, so they have their own block of IPs. I've used a /24 in this example. They have their own AS number, they peer publicly, but they have multiple data centers, so they don't necessarily have a number of IPs that would let them actually publicly peer individually from each data center and advertise different subnets from each data center. So in this case, I've gone with the /24. So this is an example type of deployment where if you had a /24, but you wanted to subdivide that across multiple different data centers, and maybe those data centers are in the same city, maybe they're in different cities or different states or even different countries. What you can do is terminate the Megaport Internet service rather than directly to a port onto your own equipment. You could terminate it onto a Megaport cloud router and have it terminate the public BGP, and then have it run internal private BGP sessions basically between your firewalls in your data centers and the MCR. And that gives you the ability to more flexibly divide public address space and more flexibly route things around. So as you can see here in the diagram in the example, basically this would allow you to subdivide that public /24 into multiple smaller subnets that you can use internally for your different data centers. So this has been a pretty popular use case that we've seen. This also lets you do. It also lets you make changes, right? It's like, let's say hypothetically in this scenario there was some kind of outage that affected the data center at the bottom there, and so you needed to shift that subnet to route to the data center in the middle. You can really easily do that. You can either do that via static routes on the MCR, or even that BGP between your firewalls and the MCR, and you don't have to kind of involve the internet in that because you're terminating your routing on the MCR. So you can really granularly control where things go and have a lot more flexibility and control over your internal routing. So that's something that we've seen that's a little bit interesting. Another design that we've seen is customers using MVE as a border router, as an edge firewall to terminate the internet connection. Sometimes they have their own IP space they want to advertise. Sometimes they buy blocks of IP addresses from Megaport. Either way, you can have the MVE basically running as a virtual firewall. So this has been pretty popular with Palo Alto and Fortinet firewalls. We support Cisco firewall as well. This basically gives you a design where you have this centralized virtualized edge for your network that connects to Megaport Internet for its public peering or access. And then you can do that, you can do firewalling and all the other bits and pieces on that MVE, and then route privately internally. So in this case, you may not have firewalls at each individual site or each individual data center. You may or may not. You may or may not choose to use public addressing within the network. So in this example here, I've got private addressing. I've got /30s for the top. So maybe you've got a /30 on a privately addressed link between the MVE and your device in each data center. The bottom one, I've got a /24 just to sort of show that you really have full control over what this looks like because you've terminated that public connectivity on the MVE as an edge firewall. So internally, you can do whatever you want. You can use larger subnets if you want to have multiple addresses on the device within the data center, or really however you want to design it. You get a lot of flexibility by having this kind of architecture. You can also put the MVE wherever it makes sense, right? So these data centers, hypothetically, these 3 example data centers here, maybe they're not all in the same place. Maybe they're not all in large facilities that have the kind of peering that you would want for internet connectivity. Maybe they're in different states even. And this gives you a way to be able to put that firewall in a place that makes sense and have that internet edge in a place that has really good connectivity and that really high performance and high resiliency, high availability type environment, and then route that out to ports and things, route that out to your locations, data centers or offices or whatever it may be, from that central point, that central hub. So I mentioned earlier that there are some high availability options, so we can provide diverse connectivity and redundant connectivity via the internet service. It works similarly to most of the way that we do diversity for the other products, in that we have different zones. We have a red zone and a blue zone available. So you can bring up a connection when you create that internet connection, that VXC to the internet. You choose where you want that to be terminated. And so you can terminate that onto the red zone or the blue zone within the metro that you're in. So we run those two zones in each metro, which are two different data centers, two different physical locations, two different physical sets of hardware. So that's how you can have that resiliency as far as the actual internet service side. You can have two separate internet services that are terminated on two different transit routers, two different I guess, customer-facing routers on the Megaport side in two different data centers. So that kind of covers you in case there's any types of outages or anything within that Megaport piece, within that Megaport Internet infrastructure. You still do, in this architecture, have a single point of failure in the physical port here. So you can see there's the customer router plugged into one physical port and two internet connections coming off of that to the two different zones. So you're covered if there's a failure within one of the zones. You're covered if there's a failure of some of the Megaport internet equipment or anything like that. But you're not covered if there's a failure of this actual access point here where you're physically plugged into Megaport, because you're plugged in with one cable and there's obviously one device on the end of that one cable. So this is essentially what you would do if you wanted full diverse delivery. If you wanted to have two internet circuits that were delivered to you on two separate physical cables, on two separate physical ports. So on your end, you can plug this into two separate physical devices if you want to maintain that full diversity of the whole path. Works the same way for MCR and MVE. If you want high availability for MCR or MVE and you've got two deployed in different data centers, you can have those two internet connections, one to each of those from separate data centers. So you've got full diversity the whole way through. All right. So what we will do is jump into the portal and run through how you can actually deploy some of these services. So this is a brand new blank empty portal, so there's no services in here at the moment. So what we'll do first off is we'll create a port. Just for example's sake, let's put this port in Sydney. Maybe let's choose CDC, Eastern Creek in Sydney. So this would be where you're physically located, where your equipment physically is that you want to plug into Megaport. Let's call this DC1. Okay. And we'll order that port. So that port's been ordered. Essentially what will happen now is the system will go and provision a switch port on a piece of equipment in that data center that you've chosen. It'll generate the demarcation details and the letter of authorization automatically, which you can download from the portal, which you would use to get the cross connect from your DC operator to plug into Megaport locally in that facility. So if you're brand new, this is sort of the process to connect to Megaport in the first place. But if you're already connected to Megaport, you'll already have this in place. You'll already have physical connectivity. You'll already have either some ports or MCRs or MVEs or something that you're currently using. So essentially what happens from here, when you've got this port in place, this is where you can now create circuits from that port, which is delivered as different VLANs off to wherever it is you might want to go. So as I mentioned earlier, obviously the major cloud providers, the hyperscalers are really, really popular destinations for that. Direct connect into AWS or express route into Azure or that kind of thing. Oracle Cloud and Google Cloud as well. There's a whole giant list. But now that that port exists, you can create a connection to the internet just natively in the portal. So the list here is sort of showing you the latency to any of these pops. So we have this local one here that's only 1 millisecond or less away. So we'll choose that we want to connect to that internet point of presence. We can see here for diversity purposes, the port is in the red zone. So we're going to choose to connect to the internet service also in the red zone. Go next. Essentially, we'll provide a rate limit here. So this is how fast we want this internet circuit to be. So let's say 1 gig per second. We can choose some other details here, similar to our other services. So you can give the circuit a name, basically anything that you'd like. You can choose the VLAN that it's delivered as. So this is, as I mentioned, each of these circuits is delivered as a tagged VLAN on the port. So let's say that we want the internet service to be VLAN 100. You can choose the term options down the bottom here. So either no subscription, which is just per minute billed. If you need an internet connection for an hour, you can spin it up in 60 seconds and then tear it down an hour later and you'll pay for that 1 hour. But otherwise, if you're looking at longer terms, you can move through 12, 24 and 36-month options to get some discounts on the pricing essentially. So I'll add the VXC to the cart and order. And that's pretty much the process. So it's that easy basically to order an internet service. So we first ordered the physical port, which is the point at which we'll plug into Megaport. And then we ordered an internet service as a VLAN off of that port. So the service is being provisioned as we speak. So again, roughly 60 seconds to provision that connection. What we'll do in the meantime, we'll create an MCR just so you can see that process. So let's choose, let's say maybe Melbourne this time. Let's deploy an MCR into M1 in Melbourne. Let's say we want to do a 1 gig MCR. Okay, we'll give it a name, choose the contract terms again, add an MCR and order now. So this would be in case you needed to do some routing within this network as opposed to just directly deliver it to a data center. So that's basically the process to deploy a Megaport cloud router. So this internet connection here that we delivered to the port, if we click into this now, go to details, we'll see that it's basically been provisioned, it's ready to go. You can see the public IP that's been assigned here. Both IPv4 and IPv6 come out of the box. That's as easy as it is, right? If you were to, on that device, configure VLAN 100, it would actually get this IP via DHCP. But you are free to set it statically as well. It is persistent, so it doesn't change as long as the circuit exists. You'll keep that same address. So if you were to configure this on an interface, point your default gateway at this address, you'd have internet connectivity. Like it's that quick and easy. So this MCR is basically being delivered now as well. And to add an internet connection off of that MCR, it's exactly the same process. So if we were to go to Megaport Internet, so this is in Melbourne this time, so we'll choose to deliver this out of, let's say, NextDC M1 in Melbourne. Next, we'll give it a speed. So let's try, let's say, 5 gig per second for this one. It's a 1 gig MCR. So you can't have a connection on an MCR that's greater than the speed of the MCR. So because I chose 1 gig when I deployed the MCR, the maximum speed of any connection on that router is 1 gig. Okay. Add VXC, and that's the process there for that as well. So it doesn't really matter whether you're delivering the circuit directly to a port, to a device of yours in the data center that's physically plugged in, or to a virtual router, to a virtual firewall. The workflow is exactly the same, takes the same amount of time. So it's really quick and easy, regardless, basically. If you need to modify the service, you can basically click in here and change the speed, however and whenever, and the price will reflect that. So you can do that during the month as well. So because it's billed per minute, you can do something like, maybe it needs to be a gig per second during business hours, but maybe out of business hours, it can be 200 meg per second. So you can automate that workflow and automate that speed change so that you're only paying for what you need when you need it. You're only paying for the extra capacity during business hours and not after hours. Let's say hypothetically you've got a backup window or something that happens on a Friday night. Maybe on a Friday night you have this scheduled to change up to, let's say, 5 gig per second for an hour or two or something on a Friday night for a backup window, and then back down. So you can hit the APIs. All of this, everything available in the portal is available via the API. So you can automate this whole workflow, change the speeds up and down whenever you like. You can even terminate the services automatically, create new ones, whatever you might need to do. You can automate all of that as well. All right. So let's see if there are any questions. All right. So can customers bring their own? Yeah. Okay. I think I might have answered this one already, but we'll go through it again just to confirm. So the question was, can customers use their own IP addresses? So yes, you can. If you have your own APNIC assigned public IP addresses and your own AS number, and you want to run BGP with Megaport using your own AS and advertise your own IP ranges, you definitely can do that. We actually do also support running BGP even if you don't have your own AS and public IP addresses. If you just want to use BGP to manage the routing and to orchestrate failover and high availability between connections, we do actually also support running BGP with a private AS number and with essentially IP addresses that you've bought or leased from Megaport. So you can do that either way, whether you have your own AS and public IPs or not. You can run BGP, you can peer with Megaport and have automated failover and all the other bits and pieces that you'd expect. Let me see if there's any other questions. Can Megaport? Yeah. Okay. Cool. So we kind of ran over this one too, but just to go over it again, we can do additional IP addresses. So the interface itself, the actual IP address on the network interface, both on the customer end and the Megaport end, it's 1/31. It's one single subnet, and it can't be changed and it can't be increased. What we can do though is once that's in place, if you need additional public IP addresses from Megaport, we can route you additional blocks of IP addresses over that link. So the interface itself will stay as that /31, but we can route you additional blocks to /29 or 28 or whatever that you happen to need. We can route that to you over that interface so that you can use those additional IPs internally. And optionally, you can advertise those back to us with BGP if you've got multiple connections and want to automate the failover and routing. Okay, can MCR? Yeah. Okay. Yeah. Okay. So the other question here was, does MCR do public BGP? So essentially, yes. So you can use MCR to terminate these connections, to terminate that public peering. MCR is just a router. There's no firewalling capabilities or anything. So usually that would be used where you want to route that public addressing somehow internally to firewalls that you then have on-prem. Otherwise, if you needed firewalling in NAT within Megaport, you'd use MVE basically. Okay, and yeah, so we're basically at the half hour. So that's all for this week. As I said, we post these on the YouTube channel. So if you've got any questions or anything, feel free to leave them there, leave comments there. Otherwise, reach out to your account team, and we're happy to jump on a call and discuss the details of that kind of thing. And we'll see you next time.